Hey everyone, just wanted to cover a new development in our side project. So we are currently working on the hypervelocity rocket. That is our main project right now, but we've been working on this on the side for a little while. And what these are is a new type of rocket. When I say new, I don't really mean brand new. This is kind of an older concept. It actually dates back to the early 1900s, but it was redeveloped back in the 1980s to 1990s by Irving Azovsky. And what these rockets are, instead of using commonly available composite propellant, which is an oxidizer and a fuel and a binder mixed together to make a rubbery type of propellant, this uses loose grains of smokeless propellant. Smokeless propellant is commonly used in firearms, so we have just an example here. For 50 BMG, this would be powder that goes into those 50 caliber rounds. Well, what we're going to do is use this type of powder in these projectiles. So these are rocket motors. These are not bullets in the traditional sense. Rather that they are containing burning smokeless powder that exhausts through a nozzle in the bottom and creates thrust. So with a regular bullet, you have the casing and the explosive charge pushes on the projectile down the barrel. So these differ in the sense that they contain a chamber that creates the thrust. Instead of using a barrel and a bolt to seal the barrel, that creates the pressure and pushes it down. So this is a self-contained, self-propelled projectile. How this works is if you just put powder in a cylinder and put a nozzle on the end, all the powder, once ignited, would blow out the nozzle. I'm going to show the CAD version of this, but what happens is the powder is poured down the nozzle and it's trapped in this dome, this chamber. And as it's ignited, the acceleration on the rocket pushing it forward pushes the powder back. So it keeps it trapped long enough for it to burn in that chamber, and then it'll flow through the nozzle and create thrust for the rocket. The kind of interesting thing about this design is that it's a lot easier to have the propellant because it's commonly available smokeless powder, and making composite propellant can take several days, and it's more sensitive to the environment than commercially available smokeless powder. And you can custom load these easier by just pouring in different amount of propellant to get different velocity. There's very limited information on the original rockets that were made for this. They used artillery propellant. They were much bigger rockets. They used a lot more powder than these are going to use. But just going off what's commercially available, we had to scale down the design to what's available. If you use too much powder and that's too small in a rocket, it's going to overpressurize. We've done rough calculations. We're aiming for 2,500 psi pressure. We expect maybe more. We're going to be remote testing these, so if they explode, it's not going to cause damage to anyone. We're just kind of proving concept that you can use smokeless powder in a rocket using this re-entry nozzle style rocket. So this is the first generation. We have the non-NFA caliber. So these are in .49 caliber. These would be fired out of a smoothbore shotgun style barrel. We could shoot them out of a rifled barrel, but they're not designed to scrape or be pressed through a barrel like a bullet is. So smoothbore is fine as long as we meet the legal requirements, making sure the barrel is of a certain length, which would be roughly about 18 inches for a shotgun. We're still working out what to do with this one, but we have an NFA caliber, which is the 20 millimeter caliber. This would be fired out of our Fliegerfaust. So this is the old generation, the first generation. For stability, it uses like an air rifle with this type of shape that whilst it's flying, if it goes out of, straight flight, the wind will push on the stabilizing flare, and it would redirect it back into a stable flight, which works to a degree. It's very effective with air rifles. But what we've done with this new generation is that we've added vanes, torque vanes, to the end of the nozzle, and that will impart spin on the rocket, as well as having that aerodynamic shape to help it fly straighter. We're also going to be adding the spin, similar to how a football would spin in the air and create stability. The idea is to do the same. So this is the new generation, and I just want to give a huge thank you to Replicator USA out of Colorado. They 3D printed these entirely out of Inconel steel. It's not a cheap thing that they did, so it means a lot to us that they're willing to print, several of them to test before we, invest more into this type of rocket. Next time I do a static test for the hypervelocity rocket, I'm going to bring these two and we can do some testing out of that. But I just want to do a better video explaining, these type of rockets. So thank you, everyone. We're going to keep you updated. Thank you so much for the support. I hope see you next time.